Hi, very good morning to one and all. I am Dr. D.HEMANAND, Professor, CSE Department, SA Engineering College. Now, I'm going to take the great coaching for the computer science and engineering students. Today, I'm going to cover the first topic in the computer networks. This is the GATE 2024 syllabus for computer networks. This covers actually concept of layering, OSA and TCP IP protocol stacks, basics of packet, circuit and virtual circuit switching, data link layer, framing, error detection, medium access control, Ethernet bridging, routing protocols, shortest path, flooding, distance vector, link state routing, fragmentation and IP addressing, IPv4, CADR notation, basics of IP support protocols, network address translation, transport layer flow control and congestion control, and UDP, TCP sockets, application layer protocols. Okay, these are the syllabus for the computer networks for GATE 2024. Today, I'm going to take about the concept of layering, OSI, TCP, IP protocol related questions. So, this is the contents I'm going to take today. The topic overview, that is, our topic is protocol layering and advantages and detailed solution to some gate questions. So first, before going to take the problems in gate questions, I'm going to give you this overview about what is protocol layering. A protocol, as you know about that, what is protocol? The protocol defines the rules that both the sender and receiver and all the intermediate devices need to follow to be able to communicate with effectively. The protocol gives you some of the rules to follow the proper communication. Once the communication established between the devices, that the communication can be governed by the protocol. The set of rules will be there. Okay, that is used to communicate without any boundary, different technology for the devices, so that can be able to communicate with properly by means of the protocols. When communication is simple, we may need only one simple protocol. When the communication is complex, we may need the very complex kind of protocols. We need to approach that the task by means of different layers in which we need a protocol at each layer, that is called protocol layering. So this is one scenario, a single layer and a three-layer protocol. So let us develop two simple scenarios to bring this to understand clearly. So this is a single layer protocol. Here, Maria, on the two persons, Maria and Anne, wants to communicate with each other. So the layer one is involved in this communication. So it is very simple. That can be occurring only one layer. So the Maria can able to listen and talk, and Hayan are also able to listen and talk with the help of the only one layer. So assume Maria and Hayan are neighbors, and communication between the Maria and Hayan takes place one layer, face to face. So the rules, some of the rules we need to keep. Okay, this is to be called as a protocol. So what are the rules we need to follow while communicating with each other? They should greet each other when they meet. They know that they should confine their vocabulary to the level of their friendship, and each party knows that she should refrain from speaking when the other party is speaking. Each party knows that the conversation should be a dialogue, not a monologue. Dialogue means both the parties have to take part in the communication. And rule 5 is they should exchange some nice words when they leave. Okay, these are the certain rules we have framed for the communication between the two persons. Okay, so the next one is three-layer protocol. Three-layer protocol. Here the layers involved in this are three layers: layer 1, layer 2, layer 3. The protocol layer enables us to divide a complex task into different smaller and simple tasks. Okay, that is the way of approach for these complex kind of things to communicate. Okay, the Maria and Anne, both of them involved in this communication. Okay, three layers involved in this communication. First, Maria wants to talk with the hand to the device. Okay, that will listen to the Maria, and that will be transferred to the layer 2. Okay, in the layer 2, the encryption, decryption will be done here, and then that information is passed on to the layer 1. Here, that what are the processed data that will be sent to the hen. So here, the medium will transfer the data, and that will be accumulated here. That will be that mail will reach the layer 2. Here the encryption, the decryption of data will be done here, and then the hen can able to listen the what Maria communicated. Okay, this is the way. Okay, we can approach the complex task. So the Maria talks to the machine at the third layer as though the machine is an and is listening to her. The third layer machine listens to what Maria says and creates a plain text. So which is passed to the second layer machine. The second layer machine takes the plain text, encrypts it, and creates a ciphertext which passes to the first layer machine. The first layer machine is presumably a robot. At the hand side, the first layer machine picks up the letter from the hand's mailbox. By recognizing the letter from the Maria by the sender address, the machine takes out the ciphertext from the envelope and delivers it to the second layer machine. The second layer machine decrypts the message and creates the plain text and passes the plain text to the third layer machine. The third layer machine takes the plain text and reads as though the Maria is speaking. So these are advantages of layering. Okay, now we understood what is layering. What are the advantages we have when you are going for layering? So we can apply divide and conquer strategy. Okay, with the help of this divide and conquer, okay, we can able to extract the advantage of layering. So the dividing the problem into different subparts and then solving them one by one. With the concept of layering, encapsulation is possible. Data abstraction. Okay, so that can also be done at different layers. Layering makes texting easy, allow us to separate the services from the implementation. The main advantage of layering is modularity also. So these are all the advantages of layering. So what are the 7 layers in the ISO OSI model? So these are the 7 layers: physical, data link, network, transport, session, presentation, application layer. Physical layer, this is the functionality of the each and every layer. Send data onto the physical wire. The examples are hubs, MIC, network interface cards, cable. Data link layer reads the MAC address from the data packet. The examples are switches. Network functionality is reads the IP address from the packet. The examples of this network layer is routers and switches, layer 3 switches. Transport layer, it is responsible for the transport protocol and error handling. TCP, UDP are the example. Session phase, it establishes the connections and ends the connection between the two hosts. So NetBIOS and PPTP, that is, these are the example for session layer protocol. And then presentation, it encrypt and decrypt the data. So what are examples means JPEG, GIF, HTTPS, SSL, TLS. These are the example for presentation layer. So application layer is concerned the services that are used with the end user application. SMTP is one of the example for the application layer. So now we can move on to the gate questions. Here one of the question is assume that the source S and destination D are connected through two intermediate routers labeled or determine how many times each packet has to visit the network layer and data link layer during the transmission from S to D. Okay, this is the question, the gate 2013. Okay, how to approach this question? Here they have mentioned that S and D, source and destination, are connected through the two intermediate routers. So once again, so here so this is source and this is destination. So here two routers, here mentioned that two intermediate routers labeled OR. Two intermediate routers labeled OR. So the data link layer, the packet has to visit the network layer and data link layer. So there are we can take TCP/IP layers. That is, what are the layers in the TCP/IP? Physical, and then data link layer, network layer, and then transport layer, and then application layer. So these are the 5 different layers in the TCP/IP protocol. So here also application, transport, network, data link, and presentation. So here to transmit the data from source to destination, these 2 layers, three layers taken into part, okay, taken into account. So first source information will reach this physical layer and up network, data link layer, network layer, and then again move on to physical layer, data link layer, network layer, and then reach the destination. So here, how many routers label determine how many times each packet has to visit network layer. Okay, now here we can have the interface. Okay, so here one interface will be there, data link layer one interface will be there, presentation layer one interface will be there. The same thing like here also. So here network layer will not be the any interface, but data link layer and physical layer we will have the interface. Okay, likewise here also we will have interface. So how many times each packet has to visit the network layer and data link layer during the transmission? So in this case, you can take the network 4 times. Okay, data link layer 6 times, because network layer don't have any interfaces here, but data link layer will have the interface on both sides. So 2 times, okay, extra it will has to travel. Okay, so this is the C is the correct answer for this particular question. What is the answer? Network 4 times, data link layer 6 times. This is the correct answer for this question. Next, we will move on to next question. So here the question, this came on the gate 2004. So what is the question here? Choose the best matching between group 1 and group 2. Group 1, they are listed data link layer, network layer, transport layer. Group 2, they have mentioned some of the functionalities. We need to match these 2 groups. So first we read out what are the functionalities here mentioned. It ensures reliable transport of data over a physical point-to-point link. Okay, this is matching or not. We need to compare these 2 statements with the first statement with the data link layer. Okay, that is matched with the data link layer. So first statement we need to compare with the first data link layer. That is okay. So it ensures reliable transport of data over a physical point-to-point link. Okay, that is matched with the group 1 P. Next, the Q, that is network layer, and we read out the statements mentioned here. So encode and decodes data for physical transmission. Okay, this is not matched with the network layer. Whether it is matched with data link layer, no. This is not matched with data link layer. Whether it is matched with transport layer, you need to check encode and decode the data for physical transmissions. Okay, this statement is not matched with any other layer given in the group 1. So next, allows end-to-end communication between the 2 processes. Okay, the third statement is matched with the transport layer. This is matched with transport layer. So next, routes the data from one network node to the next network. Okay, so this is matched with the network layer. This is matched with network layer. So when you are grouping the matching between the 2 groups, okay, when you are approaching the answers given in the list, okay, first P1, Q4, R3, that is P is data link layer, that is matched with this statement, that is correct. Q is network layer, that is matched with 4th one, that is routes data from one network to another network. Okay, next R, that is transport layer, that is matched with transport layer. Hence, first answer will be the correct one. Okay, this is the correct answer for this particular question. So next we move on to next question. That is, this is came in the year 2014. The question is, in the following pairs of OSI protocol sublayer and its functionality, the incorrect pair. We need to find out the incorrect pair in the list. That is network layer and routing, data link layer and bit synchronization, transport layer and end-to-end process communication, medium access control, sublayer and a channel sharing. Okay, all these four answers we need to find the incorrect pair. So what are the first we need to analyze what are the functionalities of the data link layer. So the statements given here is the functions of the data link layer: framing, addressing, error control, flow control, access control. These are the functionality of data link layer. So these are the functionality of data link layer. So sublayers, there are two sublayers in the data link layer, that is logical link control, MAC, medium access control. So these are, so like logical link control is a sublayer for in the data link layer, that is deals with the multiplexing and flow of data. And medium access control is a sublayer in the data link layer for the data transmission. It is also responsible for flow control and multiplexing for transmission. So when you are analyzing these four answers, okay, in the following class, OSI protocol sublayer and functionality, okay, which one is the incorrect pair? Okay, the B is the incorrect pair because network layer and router is interconnected well. Transport layer and end-to-end process communication, that is also there is some connection between the two parts. And media access control sublayer and channel sharing, that is also having the connection with two parts. Okay, this one, the B will be the answer that is don't have any connection between the two parts. Okay, that is data link and bit synchronization that don't have any connection between them. So that is the answer. Data link layer and bit synchronization will be the correct answer. So next we move on to next question. This is came in the year 2004. What is the question given here? Was revealed the question: host is connected to a department network, which is a part of the university network. The university network, in turn, is a part of the internet. The largest network in which the Ethernet address of the host is unique. That is what? Okay, this is the question. What are the answers given here? Subnet to which the host belongs. The department network. C is the university network. D is the internet. So, okay, when you analyze these answers with this question, okay, you can come with a solution that is D will be the correct answer. I will say why it is D. So, D will be the correct answers. Why the D is answer? Because address used in the Ethernet is MAC address. So, also known as Ethernet address. So MAC address of two hosts in any network cannot be the same because MAC address is a unique one. So the MAC address of the two hosts in any network cannot be the same since MAC address is assigned by manufacturer in such a way. So no system has same MAC address. So largest network will be the internet because of the MAC of two system always unique. So we can conclude that the option D will be the correct answer. Other option is read out. So next we can go for the next question. This is came in the year gate 2005. Which of the following statement is false regarding a bridge? So to answer this question, we need to have some concepts regarding bridge. Okay, some idea. So what are the answers given here? Options given here. A, bridge reduces collision domain. Bridge reduces collision domain. Okay, we need to analyze each and every statement, the options given here. Okay, according to that, we can fix the solution, correct answer. Okay, bridge reduces a collision domain. Okay, that is given here. We need to analyze this statement, whether it is a true or false. The question is given as we need to find out which statement is false. This is the correct statement. Bridge reduces the collision domain. Next statement, bridges used to connect two or more land segments. Okay. Yes, bridges used to connect two or more land segments. This is also a correct statement. So read out the next statement. Bridge reduces the broadcast domain. Okay, this will not be the true statement. Okay, next read out the next statement. The bridge is a layer 2 device. Yes, bridges belongs to the layer 2 device, that is data link layer. So we can come into conclusion that which statement is false regarding bridge. The C, option C is the correct answer. Option C is the false statement given in the 4 option. The solution, the correct option is C, bridge reduces the broadcast domain. Bridge is a layer 2 device. That is what the physical and data link layer can reduce collision domain but cannot reduce the broadcast domain. So this will be the answer. So next, we can move on to the next question. This question came in the year 2016. Which of the following is example of stateful application layer protocols? Okay, so which of the, we need to read one by one: HTTP, FTP, TCP, POP3. Okay, these are the options given here. We need to identify which of the following is examples of stateful application layer protocols. So whether 1 and 2 or 2 or 3, 2 and 3, 2 and 4 or 4 only. These are the options given. Okay, we need to identify whether HTTP and FTP. First, before going to find out the answer for this question, we need to have some concept that is stateful. What is stateful? What is stateless protocol? So we need to have some concept, clear concept idea for what is stateless, stateful. What is stateless? Stateless protocols does not require server to retain the session information for the duration of the multiple request. Each request is treated as the independent transaction. Stateful protocols, the protocols that requires the keeping of the internal state on the servers, known as stateful protocol. So, what is HTTP? You need to have the clear idea what is HTTP, FTP, TCP, and POP3. What is HTTP? This is a hypertext transfer protocol. It's a stateless protocol. Okay, no information is maintained by the server, so that it is stateless protocol. FTP, file transfer protocol, is a stateful protocol. It remembers all the log files, okay, corresponding to the client. Next, TCP is not an application layer protocol. TCP works at the transport layer. POP3 is a client server protocol in which email received held by the internet server. It is stateful application layer protocol. So, you are comfortable with handling that question. Okay, now we go for that question and try to answer for this question. So when you look at this question again, you will be very much clear, okay, how to answer this question. So which of the following is example for stateful application layer protocol? Here, the clearly given is stateful. So when you go for approaching this question, you can be very clearly say that option C is the correct one. Because 2 and 4 only, that is FTP and POP3. Okay, that is only the stateful application layer protocol. Okay, what is the correct answer? Option C will be the correct answer. Next, we move on to next question. That is, this question came in the year 2019, Australia 2019. What is the question? Consider that 15 machines have to be connected in a LAN using 8-port Ethernet switches. Assume that these switches do not have any separate uplink ports. The minimum number of switches needed is. Okay, here the 15 machines will be there. Okay, how many switches, 8-port Ethernet switches is needed to connect the 15 machines? Okay, options given here 1, 2, 3, 4. So here 15 machines will be there. So assume that these switches do not have any separate uplink ports. The minimum number of switches needed. Okay, one switch can able to, that is 8-port. So it is having 8 port 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So here, how many machines? 15 machines are there. So it will be connected Okay, like this: M1, M2, M3, M4, M5, M6, M7. Okay, this will be used to connect with the other switch. Okay, here the what is the remaining machines M8, M9, M9, M10, M11, M12, M4, M30. Okay, this is used to connect with the other switch. So here you will have the other 8 ports: 1, 2, 3, 4, 5, 6, 7, 8. So here 14, 15, M14, M15. So totally how many switches are needed? 8 port Ethernet switches. 3. 1, 2, 3. Okay, totally 3 8 port switches needed to connect the 15 machines. So option C will be the correct answer. Option C will be the correct answer. So this is the explanation. Switch is fundamentally similar to bridge, but usually supports a larger number of connected LAN segments and has a richer management capability. So number of machines given here is 15. In a LAN, Ethernet switches is having 8 ports. Therefore, number of switches is 3. Okay, this is the correct answer. Thank you. It will be, I think it will be very much useful to approach the gate question, and it will give you so many opportunities to learn the related questions, okay, available in the online. Hope it will be useful to you. Thank you. Let me continue the next session in the another video. Thank you.